In this video, I'm going to talk a little bit about looking at linear combinations of numbers, particularly using something called Bezouts identity. Now, Bezouts identity looks at how numbers compare to each other and looking at combining these numbers to make a linear combination of greatest common divisors. Now, what Bezouts identity states is that for any two non-zero integers, a and b, there exists integers x and y such that we're able to write it in the format ax plus by is equal to the greatest common divisor of a and b. Now, it's also represented in the format, you'll see it written as ax plus by equals c. Now, the greatest common divisor, remember, that can come from Euclidean's algorithm. So we can use Euclidean's algorithm to confirm what the greatest common divisor is if we're quite simply given a pair of numbers. We can then take these two numbers, jiggle them about a little bit and follow a standard set of steps and be able to write them as some sort of linear combination. Overall, what this means is that the greatest common divisor of any pair of numbers is represented in this linear combination of the two numbers themselves. So for example, the greatest common divisor of 96 and 84 can be represented as something in this format here. So we can use this idea and this thought to solve for any unknown pair of integers x and y to then write it back into that format. Now, to do this, what we can do is we can follow a distinct set of steps to complete this process effectively. The first thing we have to do is find and confirm the greatest common divisor of the pair of numbers. What this allows us to do is use the division algorithm and Euclidean's algorithm to write it in a format where we'll have the two coefficients. What we then do is we rearrange the steps from number 1 and we put it into the format where we have r equals a minus qb. So essentially writing it so that we get the remainder is equal to something, take away something. So the remainder equals some sort of combination of our two numbers to begin with. Once we've done that for each line, we'll use back substitution with this remainder format to get the numbers in terms of the original coefficients of x and y, so the a and the b themselves. Then, once this is complete, what we'll do is compare the coefficients and be able to calculate x and y from this. Now, it sounds like a complex set of steps, but actually, if you follow them the way it's written and you follow the theory behind them, it is fairly straightforward and easy to do. Best way to demonstrate it though is with an example. So what I want to do here is I'm looking to find x and y such that 21x plus 15y is equal to the greatest common divisor of 21 and 15. Now we said step 1 was to find and confirm the greatest common divisor of those two numbers, so let's do that using the Euclidean algorithm. So I'm going to start by writing 21 equals something times 15 plus a remainder. So in this case, 21 is equal to 1 times 15 plus my remainder, which is 6. So the remainder is not equal to 0. We continue on. Next step would be to figure it out in some format where it's 15 plus something times 6 plus a remainder. Well, 15 is equal to 2 times 6, that gives me 12, plus my remainder of 3. Still a remainder, we move on from there. So I know in this case 6 is going to equal something times 3 plus a remainder. Well, I know 6 is equal to 2 3s plus a remainder of 0. So that means that there, the 3, is my greatest common divisor. So my greatest common divisor of 21 and 15 is equal to 3. So that means that this original statement, I actually want it written in a format 21x plus 15y is equal to 3. So I want to look at it and write it in that manner there. So my next step was to take each of these and write it in the format r equals a take away qb. So I'm going to rearrange it each line to do that. So I'm going to start, if I started with this line, I'd end up with 0 is equal to 6 take away 2 times 3. Now that doesn't actually help me at all. Remember, we want it to be of the format 21x plus 15y equals 3. So actually, when we're working back the way, this first line here doesn't need to be dealt with. What we're going to do is start here, where we've got the greatest common divisor as a remainder, because then I can rejig it and write it as 3 is equal to 15 take away 2 times 6. I'm then going to take the previous line and I'm going to rearrange it to be 6 equals 21 take away 1 times 15. Now, how does this benefit me in any way, shape or form? Well, I know, because I've rearranged it, the statement 6 equals 21 take away 1 times 15 is true. What I'm going to do is take it and substitute it into here. The original format is 21x plus 15y. I want 21 times something plus 15 times something is equal to 3. So this back substitution allows me to take everything and rewrite it in terms of 21 somethings plus 15 somethings equals 3. So I'm going to take it and I'll rewrite it as 3 is equal to 15 take away 2 times 21 minus 1 times 15. What I'm going to do then is I'm going to expand that bracket, gather all the terms together that are like, and I should have something of that format. So if I expand the bracket, and I'm going to swap sides around just so it stays with the same format as we've got there, I've got negative 2 times 21. I'll put that in a bracket. I've then got negative 2 times negative 1 times 15. So that's actually plus 2 15s. Then I've got 1 there. So I've then got plus 3 times 15 is equal to 3. Now just to confirm this, negative 2 times 21 is negative 42. 3 15s are 45, so negative 42 plus 3 15s does indeed equal 3. This there is the original format I want. So the original format of 21x plus 15y is equal to 3. So what I can now do is take this and just compare the coefficients x and y along with the 21 and the 15 and be able to write them straight down. If I look at it, this x matches up with the negative 2, this y matches up with the 3, so from that I can say that x is equal to negative 2 and y is equal to 3. What you'll tend to find with these sorts of things is one of them will be positive, one of them will be negative. There is nothing against that. You may occasionally find both of them being positive, but that all just depends on the numbers and the combination of the numbers. But we followed those steps that we said to begin with. Greatest common divisor, confirm it. We then did our rearrangement here. We then did our back substitution and jiggled it about a bit. And then, when we put it in the format, we were able to compare the coefficients and read off the x and the y from that. Show you another example here. So let's find x and y such that 432x plus 68y equals 4. So what this is telling me is that from the format that we know of Bezouts' theorem, this is telling me that the greatest common divisor of 432 and 68 is equal to 4, just by logic and by looking at the format that it's set up. So what I'm going to do is confirm that to begin with. So I'm going to say, fine, so 432 equals something times 68 plus a remainder. So it's a slightly different calculation to think about, but if I do 432, something times 68 plus a remainder, that can be given by 6 times 68 plus a remainder of 24. So I've written it in the format we want from the division algorithm. There's obviously a remainder that's not 0 there. We can continue on with the next step. So I'm going to write it in the format 68 equals something times 24 plus a remainder. So in this case, it's going to be 2 times 24, so that's 48, plus my remainder, which is 20. Still is no remainder is 0, we still go again. So I'm going to look at something of the format 24 equals something times 20, again plus a remainder. Well, in this case, 24 is 1 times 20 plus a remainder of 4. This greatest common divisor has now come up, so let's hope that the next line has a remainder of 0. If so, we've just proven that that is the greatest common divisor. So I want to write 20 equals something times 4 plus a remainder. Well, we know 20 is 5 4s, the remainder is 0. So we've just confirmed that the greatest common divisor, 432 and 68, is 4. Just as we expected from the original format. What I now want to do is start to rearrange each of these into a format that we want. So I'm going to start by this one here. Remember, if the remainder is 0, don't worry about that line. It's no use to us at the moment for the rearrangement. Start with the next line and rearrange it so that I've got the remainder for each line. So I know in this case r is going to equal 24 take away 1 times 20. Previous line here, I'm going to rearrange and write it as 20 equals 68 take away 2 times 24. And then I'm going to take the other line there and I'm going to rearrange it to get 24 is equal to 432 take away 6 times 68. So I've got 3 lines there and I somehow want to get this 432 and this 68 to be in the bottom line. Well, what I'm going to do is I'm going to first start by substituting in here. I know 24 written in the format involving the 432 and the 68. So this line here can become 68 take away 2 times the 432 take away 6 times 68. What I'll do here is I'm going to multiply out the brackets and I'm going to simplify and gather everything together. If I were to do that, I'm getting 13 times 68 take away 2 times 432. So that there I know gives me 20, just from back substitution there. What I'm then going to do is take this expression here for 20 and I'm going to substitute it in to this one here. But you'll also notice that I've still got 24 written in that bottom line. So I'm going to take 24 and I'm going to substitute it in there as well. So again, working with a back substitution. So what I'm able to do is rewrite it. So I've got 4 is equal to what the 24 was. So 432 take away 6 times 68. It's then going to be take away 1 times the 20. Well, in this case, that's 13 times 68. Take away 2 times 432. So now this line here is written in terms of the greatest common divisor, 4, and then 432 and 68. All I do now, multiply and expand out any brackets that exist and gather my like terms. As I'm doing this, I'm going to swap the size just so it's in that format of something equals 4. I'm going to have that there, equals 4. So what I'm going to do, expand this second bracket along here, and then gather it. So I'll have 432 plus 2 432s. So I'll have 3 times 432. I've then got minus 6 times 68, then minus another 13 68s from expanding the bracket there. So I'll then take away 19 times 68, and that equals 4. What we can do is use a calculator if we want, in order to check our calculation and make sure that this is all true. If I then compare it with the original format of 432x plus 68y equals 4, start to look at coefficients, what I'm able to safely say is fine. From that, x is equal to 3 and y is equal to negative 19. Again, as I mentioned, use your calculator. This will confirm that that is true and that holds dear. So it looks like a complex set of steps, but actually if we follow them to the letter, so step 1, write it in the, confirm it. Step 2, rewrite it with the remainders. Step 3, our back substitution, and then step 4, our comparison. Do that every single time and it will work out. We'll be able to use this to write it as that linear combination of the original numbers and the greatest common divisor.